Okay, this will be our last kind of wrap-up video. I'm just going to do one more problem from start to finish. Hopefully that'll be enough. If you need more instruction or examples, let me know. I can create some more examples. But let's do a multiplication problem. And we've already done an easy one, adding two or multiplying two 1-bit numbers. So let's do a 3-bit multiplier. So let's find my cursor here. Here we are. So let me write out. We're going to do step one. Step one with a circle around it is going to be to multiply 3 1-bit numbers. Okay, does that make sense? So let's see if this time we can remember the answers, remember the inputs and the outputs without actually writing out all the different examples. So let's, I know we're going to need x and y. I'm sorry, x, y, and z because there's 3. Now what is the largest number that you can get by multiplying 3 1s and zeros together? Well, that's going to be all 3 1s multiplied together is still just 1. So this is probably not going to be that hard of a circuit. So this may not be the best example, but let's do it. So we have P for product. Now, for some of you, the hard part is just writing all the combinations. I'm going to count 0 to 7. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay? There. Try to extend that line, didn't work. Okay, so there are my, let's count 1, 2, 3, 4, 5, 6, 7, 8. I know there's 8 because 2 to 3 is 8. So that checks out mathematically. And 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. So that's all numbers. All right, now for some easy multiplication. This is like 3rd grade multiplication. What is 0 times, okay, let's make this easy. If there's a 0 in the math problem, in a multiplication problem, what's the answer? Okay, so let's just write down all the ones that have zeros. Okay, well that was easy because all those others are going to end up 0. 0 times 1 times 1 is 0. 1 times 0 times 0. 1 times 0 is 0. Okay, so the only one that's actually 1 is 1 times 1 times 1. So that means we're going to have just a very small equation, and therefore, if you cannot figure out, a very small circuit. So P is equal to, don't care, 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 I do care, X, Y, Z, no knots. That's good. Step 3, our bus. Let's see if I can draw 3 lines here. Okay, we got our bus. Let's label this X, Y, and Z. Let's look at our equation here. We just have one equation, one expression, X, Y, nothing happens to them, no inverting. And the answer to that is our P. And here you can kind of see how multiplication and adding, multiplication and are actually very similar, because think about it. Unless you have all ones in a multiplication problem, it's going to be 0. And that's probably the same rule as multiplication and the and Boolean logic and. So the logic and the math are very similar in this one example. And that's it. That, like I said, that would be a real quick one. We could have done subtraction, but on quizzes and tests, we'll mainly be doing products and a lot of adding, half adders and full adders. So really get familiar with those two circuits. But that's it. That would be a circuit. You could drop that into a machine, and that could be the product circuit. And they could add, you could put 0 and 1 and 0 into my chip, and I get a 0 out. And I don't have to know how that works. I just know it works. Just like we don't really know how a computer works generally, we just know it works. So that is a product circuit. And that's going to wrap up our discussion of really not just circuits, but we're going to kind of switch gears and move to a new Well, essentially we're kind of starting from the most innermost part of a computer, the microscopic transistors and ones and zeros, and we move to the chips, and we're actually kind of pulling out further and further. So we're still going to look at some how computers work, but in a much less abstract and more with actual components that you're probably familiar with or seeing, things like hard drives and memory and actual parts of a computer that you can see and hold in your hand. So this kind of wraps up the how they work on a very detailed level, wraps up the discussion of circuitry and um, transistors and ones and zeros. And in fact, this is now time for your test. So we'll give you a test on this next section before we move on, but so you can review and rewatch old videos and check up on your notes, ask me questions, and we'll be preparing for your test next.